We have three events called A, B, C. The respective probabilities all written out, A, B's, and C's. I'm given A intersect B. And if you have a conditional probability, go and open up first. Before you even read on, just open up the conditional so that you can see what alphabets and what signs are available to you. The three sets intersection is 7/100. So part one, let's find B intersect C. So in order to get B intersect C, we can see that it appears in the numerator of this middle term here. So we are going to use this number, 13/35. So part one, if I want B intersect C, we use this conditional formula. We move the PC to the right. So it will be 13/35 times your PC. And PC, you know, it's 7/20. So we just fill in that number, which will give me a 0.13. And part two, this time your events A and B are independent. Let's find this probability. In part two of the problem, if your events are independent, can we just write in the formula first? Independent would mean A intersect B will be PA times PB. And since I have both numbers, we're going to take that and put inside. But we don't know yet how to apply this. We have to draw a simple Venn diagram to see this. Okay, if you don't understand which region it is, okay, I just draw a quick sketch. I don't need to have a nice diagram. Let's draw in three circles. This is your A, B, and C. The part that we are looking for in A, in B, but outside C is this portion here. This is in A, B, and outside C. So how do we find that in relation to the current A intersect B that we have? A intersect B would be this blue zone. So to get the red one, you will take this blue part, subtract the middle green portion here. The blue minus the green will give you the red. And this is also how you can then set up equations. Okay, so use the Venn diagram to help in the visualization so that it's easier for you to write in your equation. So this is A intersect B, subtract the intersection of your three sets. Hence, we get that 122/625, subtract 7/100, which we can simplify on the calculator. Part three is those question types where you would like to find the greatest and least possible value of a particular set. Draw in the Venn diagram. Let me guide you through the steps for this question, slightly tougher. Okay, let's draw in a Venn diagram. Draw a big one. Make sure that your circles overlap with a big segment so that it's easier for you to fill in the numbers. Okay, I will draw my three circles this way, one on the top, and then the bottom left and the bottom right. Make them overlap, okay, in a big area, easier for you to fill in. We are going to put in the probabilities just beside the sets. Can I have the top one as A, left is B, right is C? Let's have the same order so that you're not so confused. So A's probability, I just write beside that alphabet, 8/25. B is 61/100. And C is 7/20. At this point, I may not want to fill in the A intersect C and B intersect C because they are over two regions. Like A intersect B has two parts to it. So I may not want to fill in first. But the middle one, I do know it's 7 over 100. This is that center. Before you start and try to assign one segment to be X, you should look at where they want first. A intersect B intersect C prime is here. In A, B, but outside C. Observe that it involves C prime, meaning the whole C is not important to us. I am going to overlay the set C in blue to let you know that this whole region, we will just treat it as 7 over 20, that it is fixed. I don't care about what are the values in these three regions. It doesn't affect the range of my question mark. The question mark don't involve C. So all this I will not want to find, not important for the problem. It doesn't involve C. But everything else I will want. Everything else means this red color ones, including the question mark and outside. Don't forget outside the three sets. You want to calculate them. By first setting all these red parts, look at who is the most intersected. This question mark zone is the most intersected. I will let it be an unknown called X. Okay, and that is my step 1. I will let P, A intersect B intersect C prime be an X. We want to fill up all the red color zones. So let's go with this top part first. What is this value? You go for 8 over 25 minus this intersection. So you want to minus A intersect C minus X, which you know A intersect C, so you can subtract. Okay, so I will take 8 over 25 minus that 11 over 100, which will give me here as a 0.21 minus X. Similar for the left side, take 61 over 100 and we subtract B intersect C. B intersect C you found in part 1. And you want to subtract away here B intersect C, which we will get 0.48 minus X after you subtract. Okay, don't forget to also calculate outside. Okay, so what is this outside? You take 1 minus. That is this 7 over 20 from C. And we minus away all these 3 sets that we have. These 3 purple ones. It must calculate the region outside the whole union, which we will get X minus a 0.04. Okay, so that's step 1. Step 2 is then to set all regions, all the regions that you have with X, make them positive. The reason is because they are all probabilities. Probabilities will all be positive. But I will group them into 2 types of numbers. One is those with a negative coefficient of X. Let me highlight in yellow. The other one is positive coefficients of X. Let me highlight in blue. Treat the 2 parts or 2 colors differently. Those with a negative coefficient of X, I'm going to write at one side. Set both of them to be more than or equal to 0. So if you make X the subject from here, you get X less than equals to 0.21, X less than equals to 0.48. And we draw a number line. Number line is optional. Only if you cannot see the intersection, you can draw in the number line. We are looking for this region and this region. I want to have the intersection. You want to fulfill both lines of inequality, so you will be intersecting. So here, over the intersection, we get X to be at most 0.21. And I do the same for both blue regions with positive coefficients of X. So I will want X to be more than or equal to 0, this top left one. And on the bottom right here, similar. which means this will give me x more than or equals to 0.04. The number line for this, again, optional to draw. Only if you cannot see the intersection, you can draw it out. We're looking for here and here. So we will get this region x to be at least 0.04. So what's the rationale for me to split? Why did I do the negatives one side? Because the negatives will always create a less than towards the left side. The positive x coefficients will always create the right side, will be a more than. Okay. And last step, we combine. So it means that my x will be between 0.04 to 0.21. You intersect both solutions. And we look back, is this the region that I want? We found x range. X is really the question. Question wants A intersect B intersect C prime. But you must conclude, must be clear. So A intersect B intersect C prime would also be between 0.04 and 0.21.